Hello guys, you see, kind of new topic for today, loudspeakers cable. You know, I found a cable like this. I was really happy because, it feels very nice. It's kind of siliconic cover or something, and when I open it up I realize in fact this is a microphone cable made in Italy, noiseless, low impedance and so on. Very nice cable, by the way. 2 hot wires, shielded of course, and with textile. You can see the textile inside there. I mean, this is the microphone cable you should use. Very flexible, nice. This one was used for cabinets, for speakers. It's kind of strange because I never saw anything like this. Loudspeakers cable should be as low as possible. I'm talking about the resistance. And if we look here, okay, let's measure the shield. I have a residue. Okay, let me do this in a proper way. Okay, now it's on 0, so my probes doesn't matter. Shield to shield, we have already 1 ohm. Consider this like an extra 1 ohm to the loudspeaker. You got it? Then, tip to tip, or let's call it the hot one. There are 2 of them in parallel. Both of them are already wasting or losing 1.55 ohms. And if you have an 8 ohm loudspeaker, okay, so let's use this formula. Power equals V squared divided by resistance. In our case, let's say P1 equals, let's say 50 volts squared by 8 ohms, and that means 50 times 50 divided by 8, 312.5 watts in the first example. Now remember that we already have 9.55 ohms resistance because of the cable. 155 just the cable. So P2 means 50 squared divided by 9.55. That means 50 times 50 divided by 9.55. 261.7 watts. We are losing like 20% of the power. That's a problem. 20% is a lot. Of course the amplifier is working kind of easily, let's call it. Here I have a very common automotive hi-fi. It's very popular. 110 centimeters here. Let's see. 11. Okay. So let's start all over again. We have 12.3 meters. Let's measure properly. So let's measure the mesh. Yeah, 1 ohm, almost 1 ohm, and the hot wire directly. Yeah, almost the same results. Let's say 1.5 ohms for both wires. That means 0.12 ohms per meter for the microphone cable. Dedicated speaker cable. I really don't know the gauge of this one, but let's measure the length first. 5.4 meters. And what about the resistance? You can do that with a good multimeter, so we don't need a specialized low resistance. 192 milliohms. Okay, that's fine. And you can see it's a huge difference. This is 0.12 and this is 0.035. So, okay, I'm using this for my tops, like 300 watts or something. 192 milliohms for 1 way. 2 ways, that means almost times 2, of course. Everything times 2 here. So finally we have like 0.07 ohms per meter. So we got here like 1.12. Yeah, it's almost half. Let me have another kind of cable. This is I don't know if it's dedicated, but I bought it like being dedicated speaker cable with silicone, 2 wires. Does say anything about, so I got here like I'm trying to get as close as possible to the wires. Okay, 133, let's call it pink. I have 10 meters and it's 2 times or 0.133 ohms. 133 milliohms. That means 0.026 per meter. 0.026 ohms per meter. So far is the best. This is ordinary cable for installs and all the other stuffs. It's like 2 times 2.5 square millimeters, I don't know, 2.5. Anyway, it's heavy cable, let's call it. For how long is it? 5 meters. Let's measure the resistance. 48. Okay, let's call it 50 milliohms. And times 2.02 ohms per meter. Oh, now we are talking. I was expecting that because this is a really heavy cable. Very good for subwoofers. And some other dedicated speaker cable. It's 6 meters. Okay, let's measure this guy. Okay, 152. We have 2 times 0.152 means 0.3 and divided by 6 meters, that means 0.05 ohms per meter. Not bad. From left to right. So, speaker cable dedicated is this one, number 1, okay? With 0.02 ohms per meter. Second, it's ordinary electrical cable with 0.026 ohms per meter. Here is number 3, pink, 0 to 66, of course, per meter. And then we have the speaker cable, this one here, which gives me like cable a little thinner, that gives him like 0.07 ohms per meter. And finally number 5, it's the microphone cable, which gives staging 0.12 ohms per meter. Now, if we consider power, it's square voltage divided by the resistance, V squared divided by R, where R is evidently the cable and the loudspeaker. Let's consider like 10 meters of these guys. On number 1, we have 10 meters of cable means a total of 0.2 ohms resistance. And if we 50 volts RMS at the output and then 8 ohms loudspeaker, that means ideally we should have 312.5 watts. In this case we have 8.2 ohms resistance. We are losing like 10 watts or something, like 2.4% of losing power. That's number 1 here. Second one, we have 10 meters of cable, let's call it, and that means 8.302.6 watts. That's the wattage, and that means 3.1% of losing. Number 3, well, this is pretty close, almost the same, 302 watts with 3% or something. Number 4, and we have already 287.3 watts, 8.04%. 8% already. And finally the microphone cable, which is a disaster. If we have 10 meters, that will be 1.2 ohms, and that should be like 208 watts. It's like 33% losing of power. I never thought about these things, you know, it's interesting, isn't that? So finally, never use microphone cable like this. It's nice, it's flexible, it's anything you like, but it's not good for this purpose. This kind of cable, usually it's rated microphone cable, noiseless, blah blah blah, and it's saying made in Italy, low impedance by Pro-L. Yeah, I heard about Pro-L, it's a good company. So this kind of cable, shielded, you should use only for microphone and signal cables, never for loudspeakers. Okay, I hope it's interesting. So if you have any comments, please write them down. I'll be happy to talk about and to chat about. Like always, subscribe to my channel, push the like button, I really need that. Thanks to my sponsors, Vlad from Ampia Records and Jack from States, and let's not forget Radu from Belgium. Of course, until the next one, remember, have fun. See you, bye bye.